Okay, this is practice exam AB-3, number 4. So this is one of those velocity position type problems. So a particle moves along the x-axis with a given velocity of 3t over 1 plus t squared. It says our initial position when time is 0, our position is 4. So first of all, it says determine the maximum velocity for the particle. In order to get a maximum, we have to take the derivative, set it equal to 0, and solve. That'll give us our critical point, which should give us our maximum value. All right, when we plug it back into the original equation. So you have to take the derivative, v prime of t. So that's going to be the bottom 1 plus t squared times the derivative of the top, which is 3, minus the top 3t times the derivative of the bottom 2t, all over the bottom 1 plus t squared, all squared. So I'm going to, this bottom is never going to be 0, so I really don't have to worry about the denominator. Let's just worry about the numerator, set it equal to 0, and that'll tell us when the derivative is equal to 0. So we would have distributing 3 plus 3t squared minus 6t squared on top. And that's going to be 3 minus 3t squared is equal to 0. Let's factor out a 3, and you've got 1 minus t squared is equal to 0. So our critical point, and that's where a max is going to occur, is at t equals 1. When you put a 1 in there, that quantity will be 0. So to get the maximum, we would find v of 1. So that's 3 times 1. We have to plug it back into the original 1 plus 1 squared, and that's going to be 3 halves. Okay, so we don't have a unit. All right, so 3 halves. All right, I'll stand aside and let you copy that down for just a second. Okay, part B says determine the position of the particle at any time t. So to get position, s of t, we have to integrate velocity. So we're going to have to integrate this function 3t over 1 plus t squared dt. I'm going to bring that 3 out front. That'll make, I think, it a little easier. 1 plus t squared dt. So this is a u substitution. If we let u be 1 plus t squared, then du is 2t dt. So half a du would be t dt, and that's what we need. We can rewrite this. We've still got to, we can't forget about that 3. Bring that out there, and we'll have 3 halves times, okay, so we would have t dt is du, so we'll have du over u. And that's going to be 3 halves times the natural log of the absolute value of u plus c. Now c is our initial position. We know from the beginning that our initial position is 4. So this would be 3 halves times the natural log of the absolute value of u, 1 plus t squared plus 4. So that is what you want to circle. All right, I think I can fit part C and D. Part C says find the limit of the velocity as t approaches infinity. So we have the limit as t approaches infinity of 3t over 1 plus t squared. So when you take the limits as they approach infinity, this is like a horizontal asymptote, okay? So what wins, the top or the bottom, okay? So in this case, the bottom wins. And so you just have to remember something over something big over something much